All right, so today we're going to get into buffers. Buffers are a big thing in acids and bases. Big concept. A buffer is a solution comprised of an acid or base plus its conjugate base or acid, depending on which. If it's an acid, it'd be the conjugate base of the acid, or if it's a base, it'd be the conjugate acid of the base. And so it has both of those things in it. So what it does, what its purpose is to resist a change in pH. So what happens is, because you have both an acid and its conjugate base or a base and its conjugate acid, whether we add acid or base to this solution, it's going to have both. It's going to be able to counteract both. So if we add acid, the base will neutralize the acid. If we add base, the acid will neutralize the base. So whether we add one or the other, the pH is not going to change much. And so this is good. One of the big ones, one of the big or important ones that we come into contact with every day or use every day is our blood. Our blood is a good buffer, because if you think about the things we eat or the things we drink, they have a wide range of pHs, and our pH of our body doesn't change much. So that's because the blood acts as a buffer and kind of keeps our pH inside of our body at a relatively constant pH. Now, some calculations that we're doing. This is the big formula that you're going to use. It's H plus concentration equals Ka times the concentration of the acid over the concentration of the base. So what you'll do is you'll be given, when you're doing these kinds of problems, you'll be given the concentration of the acid in the base, or you'll be given, some of the data in this equation. You got to figure out the rest. So I'm going to do number one for you on today's work. It says, what is the pH of a buffer that is 0.32 molar acetic acid and 0.13 molar NaC2H3O2, so sodium acetate. So in this case we have, this is our acid, right? And then this right here would be the conjugate base, the acetate. Because if you think about it, what's left, if we get rid of, this is an acid, it's going to donate this H. And what's left after it donates the H? It's acetate. So that's our conjugate base. So what we do from here is we take these concentrations and plug them into our formula. We want to know, we're solving for pH, okay? Solving for pH. So I'm going to do H plus equals, and you need to look up the Ka of acetic acid, which is 1.8 times 10 to the minus fifth, okay? And then concentration of the acid, which will be 0.32 over the concentration of the base, which is 0.13, okay? So I do 0.32 divided by 0.13, multiply that by 1.8 times 10 to the minus fifth. I get that. So my H plus is, let's put that in scientific notation, 4.43 times 10 to the negative fifth. And so then pH equals the negative log of 4.43 times 10 to the negative fifth. So negative log 4.43 times 10 to the negative fifth. That gets me, put it back into, so pH equals 4.35. Okay, so it's pretty basic. There are you can get into some more difficult calculations, but that's beyond this course. Like for instance, what happens if we add acid or base to this? But we're gonna just stick with this for now. Okay, so let me know if you have any questions, and have a good day.